Hey guys, welcome to a little amplifier project. We're going to be using a TDA2030A amplifier kit, 2-channel. It uses these little IC amplifiers. I can't remember what the wattage is of this thing, but based on the power supply, it's probably going to be maybe 10 watts per channel. What actually sparked my attention in doing this is I'm working on other little amplifier projects, and I came across the tin. Actually, the original tin I was going to use is right here. And, I thought, well, maybe that'd be a pretty cool little case to put something like this in. And then I actually ended up, my father-in-law gave me this case, which is way more cooler. You got, fly racing. They make like helmets and gloves, and I think there was a belt or something in this box actually. But put this amplifier in there. The case is a little big for the project, so I'm going to try to put the pots on on the sides, for the knobs and stuff, and then run wires so that the boards can be kind of centered in the machine, so you can see all the components through this little window. The inside of the tin has this padding stuff in it. I'm going to leave it in there. If I tear it out, it's going to be glue and whatnot stuck to everything. And I don't think it's going to cause any issues for heat for all the more what I'm going to do with this thing. I think it's going to be plenty well heat sinked. And it might actually help keep noise from transferring through the tin to other devices maybe. So the things we got going here is we have the 2-channel amp. It has a power switch or button. It rectifies its own power. And then there's the 2 stages. It has a bass and a treble and a volume knob. And the volume is not the power switch, there's actually a button. So we're going to put a speaker protect circuit in it. It's not to protect anything, it's just going to act as a time delay. If I was going to be using a smaller tin, I wouldn't bother even thinking about using this in this machine. But since I got a lot more space to fill, I think it'll look cooler. There's a little blue LED on there. It'll kind of light up the inside of the machine a little bit. I got power meters. These run on the power of your pre-stage, not the output. So they need to be hooked up to either. I have to see if the volume controls the like a pre-stage, or if the volume controls, the main power of the chips. I don't know. Can't find a schematic for this stupid thing, and I don't think this piece of paper in there has a schematic on it. It's just a bunch of Chinese writing. But anyway, the power supply situation is this right here is a 12 and 12 center tap transformer. It's going to run this. And then this is a 10 volt transformer, which once you rectify that, it ends up being like 13, 14 volts probably. It's going to go through to power this speaker protect, but this thing has a 12 volt regulator on it, so I'm going to tap into the 12 volt supply on here to actually run, because this needs DC 12 volts. So this transformer here will run both of these devices. This will run the amplifier itself, and then on the case we'll put the pots for the bass and treble and mid-range, and we can space them out more than what they had them on the board, because we're going to be running wires from them to the stuff anyways. We need a power switch. I do want to have some kind of LED on the outside to indicate that it's on. And then we'll have to cut a hole for the power meters. And then what else we got gonna have to do with this? I like to put some kind of lights in it. Maybe some kind of blue LEDs other than what's on this here. Alright guys, I got the little power meters soldered together. Basically you have to solder the connector to the board, and you have to solder the LED fixtures on You want to talk about some little job solder in there. I'm not a surface mount kind of person. I get annoyed. I do not buy anything that needs that. This is next to it. Anyways, I got it hooked up to my phone as my audio source, and the phone is turned all the way up. And I also got these speakers hooked up so that you can hear something. But these things run on, like, I'd say your input. You'll see what I'm saying here. Your input signal, you know, from your source, you know, like the phone or a CD player or whatever, that signal buries these meters. I'll show you here. I keep pausing it and stuff so that I don't get copyright crap. So it's pretty cool. But it spends a lot of its time buried. So anyways, looking at the, I'll give it one more time. But anyway, looking at the circuit board, and then here's the wiring diagram for the things. Your signal comes into the board, right here, it goes through a couple resistors, then goes straight to the pots, okay? And then what we'll do is we'll hook the meters to this point right here. Bam, bam. And basically the volume control in here just turns up and down the input signal. You can see here, right here's the input signal goes in. It goes through these two resistors right here over to the volume control. And the volume control, as you see here, we got these two here are the signal ins. These are the two signal outs. We'll hook the power meters to there, and then the meters will go up as we turn the volume up to the maximum volume, which is the signals coming in. So more than likely the amplifiers will not be able to handle full volume, so these things should be running in a range that's, you know, that'll work, you know, look right anyways. They won't be constantly red. Alright, I've been sitting here, a few things accomplished. I got all the bridge rectifier and all the resistors mounted to this board. And got to thinking about, you know, I've got some hardware here, some bolts and some nuts to mount the boards to the chassis. And I just got to thinking, you know, these things, holes are small, you know, so I got my bolts out. And yeah, they're not going to fit. They're too big. So another thing I came across was, what am I going to use for switches for turning on and off the speakers and turning on and off the machine. And so I decided, well, I'm going to go down to Advanced Auto Parts. About the only place that's open that is going to have anything remotely that I can use. I like these switches the best. You know, it wasn't, you know, the big metal toggles, you know, but there is some LEDs in there, so getting those LEDs to work might be a little bit of a chore, because they're made to run on 12 volts, made to be switching 12 volts, so it's just, you know, the light inside is meant to run on it. Let's see, so one of the things I'm kind of thinking how I'm going to turn on and off the speakers is the 12 volt supply that goes from the IC on this board to the relay. Basically there's a little connection right there. I'll break that bridge, and I'm assuming that's a 12 volt. It might be this one down here, but either way we will cut, you know, switch, you know, the switch will close this gap right here and supply the 12 volts to the LED on the switch. So that'll, you know, that should do that. You know what I mean? I'll have to hook ground. This is ground to the machine, and then you just run 12 volts through it. It'll turn it on. Oop, and it just flew on the floor. And then it'll supply 12 volts to that light. So given it this power, you know, the IC is designed to power these two relays, I can't imagine, you know, an LED, even with this resistor, is going to be too much for it. If it is, then, well, I guess we'll have to replace it later. Now, to get the LED to work on turning on and off the machine, I don't know. I'll have to think about it later. Right now, I'm just going to continue to put together the amplifier board and worry about it later. Oh, as far as holding down the boards to the chassis, I was at the Dollar Tree and seeing this two-sided tape. So I think I'm just going to go with that. Advanced didn't have any bolts small enough to go in there. I did get a pack of cotter pins. Figure I'll just cut drill holes in the bottom of the chassis and use like cut pieces of ink pen or something, like you know, that casing to an ink pen. Just cut little sections out, put underneath, then run the cotter pin through, bend it over. And then I went to the Dollar Tree and seen this. I'm like, well, I'll just use that. I actually seen a roll of this stuff at the Advanced Auto Parts, but they wanted like $18 a roll. You know, of course, it was made to hold, you know, molding strips and stuff to your car. This right here, just, I think it'll work for what you know, for indoor type thing. I also like to mention that as I've been sitting here working on stuff, I've been paying attention to these meters, turning up and down the volume on my phone. They seem to be proactive with, like, no matter what level you have coming into it, it tries to be as flashy as possible. Like, there is no way you can adjust the thing to where it's actually going to be, you know, some kind of accurate metering device. It's designed to be flashy. It's designed to be flashing clear up in here to the red. No matter what input volume you have it, at least either going from next to nothing really moving to it's, you know, and then even then, like say it's a real quiet song, it'll be clear up here, and then boom, it'll go, you know, like when the drums and stuff kick in, it'll go down here to bury, and then it'll kind of like adjust itself back a notch to be flashing somewhere in the 3/4 range. It just seems like, you know, no matter what, I'll never get this thing to where it's some kind of metering device. It's just meant to be flashy and moving to the beat of the song. Alright, we got all the capacitors installed, and I upgraded the two main filter caps from 2200 microfarad to 3300 microfarad. So same voltage caps, just bigger value. It'll be fine. These little diodes will be fine to charge up, you know, that much more. It'll just be probably a little bit better performing generally. You can't ever add too much capacitance, seems like. Looks like there's little jumpers in here. Like I gotta put little jumpers, like use the legs that I cut off of stuff. There. One over here, I believe. Let's see what the directions say. The directions say put little funny little shape to funny little house to funny little shape to R4. Okay, makes perfect sense. Alright, since the last take I've gotten a lot done with this thing, but and had some problems, but I want to give you the sound test and visual thing here before my player goes to sleep. The meters do a pretty good job about being rated at certain volume levels. It's a little lesser than more than other, you know, when the more you give it, the more it's up there. But it does still seem to do this thing where if it's blasting loud, it'll bring itself back down, and it does try to be more visual at lower volumes. But it's definitely not a metering device. But anyway, since the last take, we got all the pots wired up to wires here. There is some buzzing going on, but basically I think it's just because like nothing is grounded to, you know, like these right here would be grounded to the case, and the case would be grounded, and right now nothing is going on like that. So it's pretty quiet considering. I really, the way it's looking so far, I don't think it's going to be a buzzy thing. I had some problems though. I was hung up for almost 2 hours over these junk pots that came with it. You know, I was turning up and down the volume, and the volume was working good, but only one channel was working. And I was pretty quick to realize the treble pot was junk. Basically, it had no treble on one side, and you like squeezed it and stuff, and then it would come in. So I pulled those out of a 30-some-year-old machine, and the same way with the volume was actually one that was getting me real good. Squeezing it really didn't do anything. And even jumping across the leads, you know, if you jump across the one set of leads, the channel it was working would go blasting loud, and then you jump across the other leads, it still didn't have any volume. Was double checking and triple checking all my solder connections on the board. I mean, it was just chasing me around, and then I just decided to change the pot, and now I got sound on both sides. But it was something else. Okay, this thing right here, the speaker protect. I currently have it hooked up that it regulates or the power and supplies the power to the meters. Right here's the transformer for it. The amp has its own transformer, and this whole setup here has its own. But anyways, what's going on with it is I wanted the delay on both the headphones and the speakers when you turn it on, and same way instant off when you turn it off. So we got 2 relays down there for the speakers, and we got a relay here for the headphones. And basically what I did was, when it normally closed, this thing powered off, it's on a connection that it doesn't use. So I wired the headphone relay to those normally closed positions on those relays, broke the connection to that powers these relays down here for the main speakers, and put them on a switch. You can see that LED down there dimming because it draws down the power supply. Now basically this relay here comes on and is powered all the time, but the connection for the speaker's sound going through it is broke whenever you turn on those down there. So when you turn on the machine, if its speakers are on, the speakers will turn on, and if you switch this, the speakers will turn off and turn on the headphone jack. Right now the speakers are not hooked up through this, but I don't think I'm going to do a mock-up of that. It's just pointless. It's pretty self-explanatory how that's going to go, and I don't think I need to do a mock-up of it. So yeah, this is kind of a mess looking, but it'll flip upside down and you'll see this side of it, and the wires will all be right here. The kind of thing what I'm going to do is like zip tie this down to the chassis. I got that 2-sided tape holding this down so far. But pretty much what goes on now is that it needs a bunch of holes drilled or slots cut, you know, with like a Dremel to get this to go in, you know, things like that. Oh yeah, I forgot to mention, I've been running this for quite a while, testing the power supply here, basically because now it's running this thing, which is not intended to, and it's also running an extra relay. But it's doing just fine. The bridge rectifier is stone cold, and the regulator is stone cold. The IC doesn't seem to be, getting hot or anything that can, switches everything on. So it seems to be doing just fine. Best way to test this stuff is turn it on and let it play for a while. Okay, here's I've been cutting and drilling holes in the case. Best I could do with this display was just cut a hole, put clear blue tape on there, stuck it to it, and then taped it on the inside. Might do something different with it later, but I don't know. This will be the power switch. When you turn it on, I got this so it used to be a momentary button. I ripped all the guts out of it, put a LED in there that'll light up when I turn it on. Speaker switch will be speakers, headphones, speakers, headphones. The headphone jack, forgot all about it, and I had all these holes kind of evenly, and then right at the last minute I really remembered that. So what I'm going to do is probably bass, volume, and treble, and then the headphone jack. And on the back of it, we got a fuse holder. This is a hole where I'm going to run the input line, which I'm just going to use like the 1/8 inch, like it plugs into your headphone jack. I'm just going to use a cord like that going into the amp, because I'm either going to be using a phone for my audio source, a computer, or an MP3 player, which all three uses. So I just don't see a use in having RCA jacks. And then here is the line in, and then it'll have an extra receptacle on it. Just it's there because it's there. I'll probably hook it up because it's there. And the speaker connections. And so I guess it's ready to start putting guts in it. Alright, it's now completed. I had trouble with the other relay to pass the signal for the headphone jack. It was a used relay, and of course there isn't a whole lot of resistance on the headphones, so it couldn't even break through a nice connection through the contacts on the relay. It came out of an old receiver or something. So rather than like pop it all off and pop the cap off and trying to clean them, I just removed it. It still functions as it should. Like this way is speakers on, that way is headphone, speakers off. But the headphones are on while you're playing music, which is typically the way most older receivers were. So it was no different with that. I built a bridge rectifier, put a bridge rectifier in here, and a capacitor and a dropping resistor for power light. All the components are zip tied down with some insulating material between the boards. Again, I guess we'll put the top back on it, see what it looks like, and give it a playing test. Alright, here it is with the top back on it. I like to mention that the feet are actually knobs, and it does have the slightest bit of noise. Let's see if I can go down here in front of the mid-range. I don't know how loud you guys can hear it, but even with headphones on, as long as even somebody's talking through the headphones, you don't really notice the noise. But it does have noise, and I think it's due to a lot of a part of it. Some of my trying to get everything in this window area, is one of the things. Trying to get everything in this window area. I got 120 volt lines running with some of the signal, speaker signal wires. If it was laid out a little differently, maybe all the power on one side, and then the amplifier the furthest distance away, it probably would have been perfect. But who knows? It may not have been. It seemed to be a plague with any time you build your own amp thing, as you can see with other people's videos. But alright, I'll turn it on. Turn it down so I don't get copyright. It's quite powerful, actually. It's supposed to be 15 watt per channel. I can't say when I was just driving one channel, it's a lot. You can really jam one speaker with it. So it is limited to the power supply, the current. And that was full blast. But yeah, I think for a little project, I think it turned out pretty decent. Well, I'll catch you